Welcome back, chat. Today we are knocking out 3.3. And within, what's up? No cap, my guys. All right, 3.3. We're looking at properties of logs. And I know that we had a small subsection called this yesterday where we looked at some of those basic properties. These are the powerful ones. Okay. I'm just going to list a bunch of properties for us, and we're going to use the heck out of them, okay? Cool. So there's really two things that we want to do. We either want to evaluate a log, which if it's base and argument match up in some specific way, it's super easy to do. Log base 5 of 5 is what? 1. Okay. Do me a favor real quick. In your margin, this is an easier answer. I want you to try the following. Solve the following equation, just off on the side of your page. We've solved exponentials, right? If 2 to the x is equal to 16, we can solve for x. Okay, solve this one. I want 2 to the x equal to 12. You're going to be able to estimate. Sorry, I've gone through this. Okay. Can you write 12 as the power of 2? Not really, right? Huh. Can you write 2 as the power of 12? I can't do that either. Can you estimate for me 2 to what power about is 12? Do you know powers of 2 pretty well? 12 is between two different powers of 2. Which ones is it? It's between 8 and, which is 2 to the 3 and 2 to the 4. So I know it's between 3 and 4. I know that much for sure. But we don't have a way to solve this right now, yeah? Can't do it. Can't make a match. However, we can, and we will here in about 10 minutes. So we have two different types of properties that we're going to look at. We have first, and this property is really chill to look at, is how do we evaluate them? This meant a lot more 30 years ago. Okay, it still means like it's still useful to us, but 30 years ago, what did every student not have in their pocket or on their desk? Didn't have that fancy calculator. There used to be these things called slide rules, which are awesome. It's like a ruler with a piece that slides, and it's like the old-fashioned calculator, but it's mechanical. I have one at home. I'll try to find it tonight so I can show you guys, but it's how people do like big multiplications and engineering math quickly on the job. Okay, anyway, if we want to evaluate, let's say log base b of x. Unless these are related really nicely, that's a challenge to do. Like, just like the example I had, 2 to the x equals 12 is the same thing as me asking you to evaluate what? Log base 2 of, like that's the same problem, right? This is a hard one to do because those argument and the base just don't match. However, turns out there's a shortcut. There are two routes that we can take. This is a weird idea because it's not really an exponent, right? X is not an exponent of b. But if I say just look at the b and the x, the base and the argument, which one's the upper number? Higher up, literally higher up on your page. X or b? X, which means the lower number is, okay, you have 3 options realistically, 2 that we're going to talk about right now, and I'll show you the third. Okay, first one, we could say, hey, this is actually just log of, what's the upper number again? X divided by the log of, what's the lower number? B. Do me a favor real quick in your calculators. Let's do this example. So I have it evaluate, and I'm just going to put an example right next to it so we can use it immediately. I want you to actually find me log base 2 of 12. Using this, it would be log of what number? 12 over the log of what number? Ask your calculator real quick, what's log 12, close your parentheses, divided by log 2, and again close your parentheses. Between 3 and 4 is my guess. I don't. Hey, is it exactly 3.5? That is wild. You got me good. Approximately 3.58. Which means if I said, hey, 2 to what power is 12? You know the answer now is, oh, it's 2 to the 3.58, blah, 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 blah. I didn't even check the rounding. Cool. That works fine and dandy. The common log is okay with this. Check it out. Or the natural log of x over the natural log of b. The most common mistake that somebody makes when typing this in, if I type this into my calculator, and don't write this, I just want to look at it, divided by ln b, what is my calculator going to do? It's going to try to evaluate this. Natural log of x over the natural log of, like, it doesn't understand. The parentheses are so important on your calculators. Anyway, we can use base 10. We can use base e if we want. Do me a favor again on your calculator. Ask it real quick. What's the natural log of 12 over the natural log of 2? I have a feeling it's probably 3.58. Okay. We now have a way to evaluate logs of wonky numbers. And it turns out, doesn't matter what the base is here, we could use whatever we wanted. Or, I'm just going to let another number exist, and we're going to call it r, just because. If I took log base r of x divided by log base r of b, I get the exact same thing. Whether it's base 10, as long as it's the same log base on numerator and denominator, we get the same answers. Okay, this gets super handy. Which one do you think I default to when I'm writing, when I'm doing math? Log or ln? It's ln. Why? Because check this out. Stopwatches. Somebody count consistently, okay? All right. 3, 2, 1. Okay, took me 5 of your counts. Okay, do it again. 3, 2, 1. Oh my gosh, my efficiency just increased by like 50%. It's huge. I'm lazy. I'm never going to confuse an ln with a 10, nothing like that. This is what you're going to see me do every single time. Okay, neat. This has a name. In your notes, this is like the ugliest notes that I think I've ever written, just because they don't fit really well. This gets a name. We took log base b of x and we changed the base to what here? Log base something of x and log base something of b. We changed it to log base. So more specific, don't you write this. If I wanted to write the base because I'm obnoxious, what's the number I write? On this one particularly? Log base 10. I changed it to base 10 here. I changed it to base what here? And I changed it to base r. In each of these cases, what did I change? Check it out. This is what is known as the change of base formula. Okay, your calculators. I'm not even going to show you because it's just as easy. Your calculators use this when you type in log base whatever of whatever in your calculator. I don't even need to show you how to get your calculator to do that because you just do ln of the top divided by ln of the bottom every time. Cool. This property is okay. It's fine, whatever. More than this, what's more powerful is the ability to use our logarithms to rewrite expressions. This is where logs become truly powerful. Now, we need to be able to evaluate them if we get weird ones via either a big book that has a bunch of log values, a slide rule, or a calculator. We need to be able to get the numbers. But this is the real power within these guys. So we get a couple different properties, and I love this language. I'm not going to write it. I will. I lied. First comment, logs are inverses of what? Inverses of exponentials. Okay, nothing too crazy. They undo them. We know that. Okay, logs are inverses of exponentials, which means some properties, and I don't know why I like the way that this word feels when I say it here, some props of exponents, or of exponentials, if there's properties that are present with exponentials, would it make sense then that they're also present with logs if they're just inverses of one another. And I wrote this word like 10 years ago when I wrote it, but I say leak into logs. And it just feels like the right thing. You don't have to use that word, but I don't know, it just feels like it fits perfectly. Log properties, exponential properties, same things, like same relation. Now, as we look at this, there's only 3 properties that I'm super concerned with today, and let's get them. So properties. We're going to take like 30 seconds. Help me find a way to alliterate don't write with a color that shows up in white.
Why would you write in white?
Why would you write in white?
Well, because normally we used to use if it's white, don't write, yeah? So I'm trying.
Can't walk.
I know, that's why I need to pick a different color.
Oh.
But I need alliteration.
Okay.
Oh.
Give me a second.
I thought you were saying find one that matches with white.
Okie dokie, there it is. Gosh, you're just killing it, man. Okay, follow it. Where's brown on the color spectrum? Is it like orangish?
Yeah.
I don't know how to make brown.
Right there.
Right, is that
That's
brown?
it?
That looks pretty brown to me.
If it's
If it's brown, put the pencil down. Okay, cool. I might have to make a little bit lighter brown just so it's a little bit clearer because it could look like black in the right circumstance. Okay, remind me of this property. If I have a to the power of x times a to the y, I'm taking a product, yeah? What happens with the exponents? They add. And in my mind, the stupid device that I use, if it's a product, they plus. This becomes a to the x plus y. Okay, so 3 properties that we get. If you want to include your log properties or the exponential properties, you're welcome to. But 3 properties for us. Nope, that's brown. I need your pencils up. Okay, first off, we have the product property. Now, there's some stuff that I'm just going to put here to make sure that we have. We're going to say that u and v are just positive values. We don't have to write it down because it wouldn't work if they weren't. I'm going to use u and v here in just a second. If I wanted to take the log and u is multiplying by v in here. This is similar. Now, I see that they're multiplying, which we're going to connect this back. If we have exponentials that multiply, what do the exponents do? They add. So what do you think is going to happen if my arguments multiply? They add. Now, we have to do this really carefully. All of your attention needs to be here. There's easy mistakes people make. We are going to rewrite this and say, oh, this is true, but it becomes the log of u plus the log of v. They add, just like they add here. If you're dying to prove it, we can. The common mistake that people make. I'm not even going to change it yet. We won't talk about it until somebody makes it, but somebody will make it, I guarantee it. All right, give me another exponential property that you know. Division. So if we have a to the x divided by a to the y, what happens? So if I have division or quotient, we'll just call it the division property. I'm fine with that. If I were to take, and notice, this is log base what? 10. Would it work with log base 4? Same thing, just uglier numbers, which means here's that lazy thing we talked about. Am I ever going to write log again? Not unless it's absolutely necessary. If I took the natural log of u divided by v, what do you think is going to happen between the logs? Love it. Natural log of u minus the natural log of v. Cool. Last one, we can reason this out. If I said, and I'm going to do it in brown again over here. So let's look. If I wanted to take the natural log of a to the 5th, for example, do you guys agree that that is just going to be a times a times a times a times a? So we will never do this, but this would be ln of a plus, I think, right? Because we're multiplying. Ln a plus ln a 5 times. So I'm going to change this to the 3rd so I don't have to write anymore. That's a 3. Everybody agree that using our first rule, this is what it becomes. Man, if only there were a more convenient way to write this. How many natural logs of a do we have? Is that the same as just doing this? So, if only there were a shortcut here, and this is a power property for logs. This one's a little bit harder. I'm going to use the number n. Okay. The natural log of, let's say, u to the power of n. Is there a shortcut that could have skipped this line? It's almost like I can physically grab that 3 and move it where? Push it out to the front. So if I could magically grab this n and push it out to the front, it would just give me n times the natural log of u. This works. If you are just dying for the proof, and I know that there's somebody in here who's not, and realistically, I'm just going to ask the opposite. Anybody kind of interested even a little bit in the proof? Ow. Ow, ow, ow. Somebody's being shy, I'm certain. Maybe everybody's being shy. If you are just dying to know and you're thinking, man, Holloway, I really wish you would just prove these. I'm so sorry the classmates just don't want it. Page 258. If you want to see the proof, page 258. I got you. Okay. Proofs are on page 258. All right, I kind of want to prove it still. That scared you? Good. Maybe just sudden changes of volume will be good to keep everybody paying attention. Now, as we go through these properties, they can do one of two things for us. They can either take an expression like that's separated by plus or minus or whatever, and they can squeeze it all together. Like take it and condense it down. That's one thing. Or from time to time, maybe it makes more sense and is more useful to take something like this and expand it all out. I can go either direction here. So when we look at these, last little comment that I'm just going to make here, we can, or we will rather, use these properties to expand or condense logs. And with that, that's like all the new material. That's everything new in this section that we have. What haven't we done yet? Well, we probably need some examples unless you guys are saying, oh, these definitions are enough and now I can do them. Let's do a couple to see how it goes. I have no preference. They are not, one's not harder than the other. Are we condensing first or expanding? Rafa, what are you feeling? Condensed or expanded? Cool. Let's expand some logs using these properties. I'm going to keep these properties up as long as I can, and I'm going to move this example up afterward. So, hey, look at that. We can expand logs. Cool. Help me build an ugly one. Example A, I want the natural log. We're going to do an awful one together. So right off the bat, I know there's going to be a fraction. Let's say we have x to the 5th times the cubed root of y over e to the power of z. Yuck. Or not. I don't know. Now, it looks awful. For sure it looks awful. We're going to be able to expand this super easily. When we expand, it just says use these properties anywhere that they fit. Now, the order in which you do this doesn't really matter as long as if there's like a product or something in the denominator, which winds up subtracting, we wind up using parentheses. I will tell you, on the test or quiz, I don't know which one, every single time I've given a test or a variation of the test, that's where people lose points, is when we divide by something and it gets ugly. So let's just look at this. Walk me through the properties. Do we have some multiplication going on? So I know something's going to add, right? The logs add. Okay? Do we have some division going on? So there's going to be subtraction somewhere in here. Is there any powers? There's another one hiding in here too. We'll get there. First thing, do you want to keep it as a fraction and then deal with the other parts, or do you want to just change it out of fractions first? Getting rid of the fractions first is probably easier in my mind. So let's just look. If I see this form, right? U is just ugly in this case. I simply take the log of the numerator and I do what to it? I subtract the log of the what? Denominator. Now, we're just going to go step by step. Let me know if I lose you. Using that division property, I think this becomes the natural log of x to the 5th times a cubed root of y. And I'm going to rewrite this real quick, actually, because cubed root of y is ugly. A cube root, is that an exponent? Y to the 1 over 3. So I'm going to write this out. The cubed root is y to the 1/3. That's my numerator. And I close the parentheses. I now subtract the natural log of what? E to the power of z. Have I lost anybody yet? To move between these steps, which property did we use? Division property. Or the quotient property if you'd rather, whichever one you want to use. Now, it doesn't matter which property we use next. I have a natural choice. What do you see, JV? I want to, let's just focus on this one for a second. Is there a property that we can use? Good. If anybody was thinking the power, I would hold off on it, and we'll see why here in a second. If we use the product rule, it says, hey, these things are multiplying, and it now looks like this. This becomes a natural log of what's the first thing in my argument? X to the 5th. And then I'm going to close this, right? Plus the natural log of y to what power? The 1/3. And it's still minus the natural log of e to the power of z. We used the product property just now. Anything crazy happened yet? This last property is so easy to use. I have nothing but powers left. Anytime that I have something to a power inside of the argument, where does the power go? Kick it out to the front, right? Cool. Man, Abigail, power prop this one for me. What do I rewrite instead of the natural log of x to the 5th? Love it. 5 times the natural log of x. Kalisha, on natural log of y to the 1/3, what would you like me to rewrite this as? So what do we do with the power? Times, and I'm using this one. This stayed, right? This, in this property, this moves, and it's ln of u still. So this moves, there's my 1/3, and it's still the natural log of what? Because we need, just kidding. Cool. Minus what, Ken? What moves to the front of the natural log of e to the z? Oh my gosh, it's z times the natural log of e. Are we done? Kind of. You could stop here. Something about this annoys me, though. Do you know the natural log of x? Yeah, me neither. Do you know the natural log of y? Yeah, me neither. Do you know the natural log of e? Me too. E to what power is e? So this is really just a 1, right? Because the natural log of e is 1. I would go one step further. This is 5 times the natural log of x plus 1/3 times the natural log of y minus, what remains? Z. And look at that. We have expanded this log. It looked awful to begin with. Now it just looks bad. Cool. Super hard. It's weird the first time. You need to have these properties locked in. I'm going to give you guys one. And I'm going to give you the one that I made a comment about that everybody gets wrong on the quiz. Cool. Do we have physics homework today? I should probably give you some homework then. Well, because otherwise you're going to get physics and pre-calc homework in the same night, is what I'm thinking. I want you guys to do one for me. The natural log of W over X, Y. At least for today, I would show every step along the way. I see like 2, maybe 3 steps. I'm gonna give you a minute. This evening, I'm not gonna give you any more homework. Somebody, if you get this answer, I'm gonna show you the wrong answer. I'm not gonna tell you the right answer right now. I'm gonna tell you the wrong answer. The wrong answer that people regularly get would be ln W minus ln X plus ln Y. This is wrong. This is wrong, and you need to tell me why tomorrow at the start of class. Peace out.
Look. Is this right? Right here?
How do you even get
Not quite.
Not quite.
How do you even get that?
You need to go for them. So now I have a product. Yep, and so this is close. Yeah, it's a good first step. But there's more to do. Abigail, did you discover it yet? Okay.